The notion of a for loop or a while loop extends the ability to write programs considerably for us. That generalization of a concept of iteration goes much beyond what we could do with simple branching programs. Remember, with a branching program, based on a test, we could either execute one piece of code or a second piece of code, but we would then proceed below that and would not be able to repeat that code in any significant way. With an iteration, we can now do more. We can use the same code multiple times. As with a branch, we start with a test. If that test is true, then we're going to execute the loop body once, go back and check the test again. And we'll keep doing that until the test evaluates to false, at which point we go to the code following the iteration statement and execute that. So this says we can go through this loop multiple times before we come out. Whereas in the branching program, we only went through the code once before we executed. That's a powerful tool, and we're going to capture that a lot as we move forward. Here's an example that will give you a sense of this. And the example here is to do squaring by repetitive addition. So another way of saying it is, if I wanted to compute n squared, that's n plus n all n times. I could write a little piece of code to do it. I've got it here. I'm going to run it in a second. I'm going to start off with something that I want to square. In this case, x is equal to 3. I'm going to start off with an initial value for answer. That's going to be where my answer goes. And I'm going to keep track of how many times I need to go through the process. Remember, I said that before about loops, like while loops. I need to set a variable outside. Then I'm going to see, do I have anything left to do? And if I do, if I'm not down to 0, I'm going to increase ants by x. I'm going to decrease the number of steps by 1. And I'm going to go back around the loop. And I'll do that until I'm done. So if I look at a version of that over here, now in my IDE, I've got a little file I've written that is going to do that. It's exactly that same code. And I'm going to load it into my environment. And wow, there it is. It printed out, as you can see on my little computer screen, 3 times 3 is 9. It ran through that loop. Just to check it again, let's make something a little bit bigger. I'll change x to 5. Again, I'm going to load it and run it. And it computes the computation as we'd expect and returns 5 times 5 equals 25. Okay, big deal. I can square things. But what I want you to see here is that idea that I've now got a loop that lets me use the same code arbitrary numbers of times. When x was equal to 3, I ran through this portion of the code 3 times. When x was equal to 5, I went through it 5 times. That's a notion of iteration. That's really useful. Let's make sure it really did what I thought it would by actually stepping through this. Again, I've got a copy of the code there. And on the side, I've got a little table that gives me the values I'm going to use. I'm going to start off with x equal 3. That comes from that statement. I'm going to start off with answer equals 0. That comes from that statement. And I'm going to start off with the number of iterations left equal to 3, the value of x. Here's what the code does. First thing it does is it checks to see, is iters left equal to 0? So it does that test. Answer is no. So what does it do? It takes answer and x, adds them together, gives us a new value to store an answer. It takes iters and reduces it by 1, restores a new value. Now I've got another version of the computation. The while loop says go back around. I check, is iters left equal to 0? It's not. So same process. The current value of answer, or ants, which is 3, is added to x to give me sex. Iters left is reduced by 1. Go back around the while loop. Is 1 equal to 0? No. One more time. Change answer by incrementing it by 3, the value of x. Change iters left by 1 to get it down to 0. Now check. Is answer left equal to 0? It is, and I return 9. And aren't you glad I didn't pick 27 to do this on, but it's something simple like 3. My point is, you can see how the while loop executes appropriately. It keeps reducing one variable, the thing that's counting how many steps I want to go through here, while accumulating an answer in ants as it goes through. And you see the properties we need for this kind of a loop. I need to set the variable outside the loop. I need to test it to determine when it's done. And I need to change the variable inside the loop in addition to whatever other work I want to do as I go through this. And in fact, what we see then is that we've now got a greater capability. Branching structures, things like ifs, only let us go through a different piece of code based on a test once. They run in constant time. They're only going to go through the code once. Looping structures, like whiles, let us repeat code until a particular condition is satisfied, but now the amount of time that it takes is going to depend on the values of the variables, as well as the length of the program. And later on in the course, we're going to come back to look at that in more detail.